Hello there, and welcome to Sleepy Universe. I'm so glad you found your way here tonight. Perhaps you've had a long day, or maybe you're simply the kind of person who finds peace in quiet knowledge and celestial wonder. Either way, this moment is yours. You have nothing to do but rest. Let your shoulders drop, your breathing slow, and your mind grow soft at the edges. Because tonight, we're not rushing anywhere. We're drifting gently upward toward Earth's oldest companion, the moon. For billions of years, it has circled our world in patient silence. A quiet guardian in the night sky, close enough to see, far enough to inspire wonder. It pulls the tides, steadies our seasons, and lights the darkest hours with borrowed silver. But beneath its familiar glow lie mysteries. Ancient craters, frozen water, dust that has rested undisturbed for eons. Mountains taller than any on Earth. Footprints that will last 1,000,000 years. And a surface so still, so timeless, that it holds the memory of everything that has ever touched it. Some of what you hear tonight may surprise you. Other facts may simply wash over you like moonlight through a window, gentle, curious, and quietly unforgettable. If these calm lunar explorations help you unwind or give your restless mind a place to land, consider liking and subscribing. It helps others find their way here too. One sleepy soul at a time. Now settle in. Close your eyes if you'd like. Let the world fade. And let's begin this slow, soothing journey through the wonders of the moon. The moon is drifting away from Earth. Every year, the moon moves a little farther from us. Not much. Just about 3.8 centimeters, roughly the length of your thumb. But over millions of years, that distance adds up. Billions of years ago, the moon was much closer, looming large in the sky and spinning faster. The tides were stronger. Days were shorter. But gravity is patient, and tidal forces have been gently pushing the moon outward ever since. One day, far in the future, it will drift so far that total solar eclipses will no longer be possible. The moon will appear smaller in the sky, a distant memory of what it once was. But for now, it still hangs close enough to watch over us. A slow goodbye written across the ages. The moon has no atmosphere. When you look up at the moon, you're seeing a world laid bare. There is no air, no wind, no weather. No clouds drift across its surface. No storms rage in silence. The sky above the moon is always black, even during the lunar day when the sun shines bright. Without an atmosphere to scatter light, stars remain visible at all times. There are no sunrises painted in color, no gentle fades to dusk, just harsh transitions from blazing light to frozen shadow. This lack of air also means there is no sound. If you stood on the moon and shouted, no one would hear you, not even yourself. The silence is absolute. In this airless world, the moon waits, untouched by breath or breeze, holding its stillness like a secret. Footprints on the moon last for millions of years. When astronauts walked on the moon during the Apollo missions, they left something behind. Footprints. And those footprints are still there, exactly as they were decades ago. On Earth, wind and rain would erase them in hours. But the moon has no wind, no water, no erosion in the way we know it. Its surface changes only through the slow accumulation of micrometeorite impacts and the patient redistribution of dust over eons. A single footprint pressed into lunar soil could remain visible for 1,000,000 years or more. In the quiet sea of tranquility, Neil Armstrong's first step is still imprinted in the dust. A mark of human presence, frozen in time, undisturbed and enduring. A whisper that says we were here. The same side of the moon always faces Earth. No matter where you are on Earth, you always see the same face of the moon. The other side, often called the far side, remains hidden from view. This isn't coincidence. It's the result of tidal locking, a gravitational dance between Earth and Moon that has synchronized their movements over billions of years. The Moon rotates on its axis at the same rate it orbits Earth, so one hemisphere is always turned toward us. The far side was a mystery until spacecraft finally photographed it in 1959. It looks different, more heavily cratered, with fewer of the dark plains we call seas. But from Earth, we will never see it with our own eyes. The moon keeps one face toward us, steady and familiar, a constant companion that never looks away. The moon causes the tides. Twice a day, the ocean rises and falls in a rhythm as old as time, and the moon is the conductor. Its gravity pulls on Earth's water, creating bulges on the side facing the moon and on the opposite side as well. As the Earth rotates beneath these bulges, coastlines experience high and low tides. The sun also plays a role, but the moon's influence is stronger because it is so much closer. When the sun and moon align, their combined pull creates spring tides, the highest and lowest of the month. When they are at right angles, we get neap tides, gentler and more subdued. This ancient pull shapes shorelines, guides marine life, and reminds us that even from 250,000 miles away, the moon touches the Earth with invisible hands. The moon was likely born from a collision. Long ago, when the Earth was young and still molten, something catastrophic happened. A Mars-sized object, sometimes called Theia, slammed into the early Earth with unimaginable force. The impact was so violent that it vaporized rock, melted the surface, and sent massive amounts of debris spiraling into orbit. Over time, that debris coalesced, cooling and clumping together under its own gravity. And from that cloud of shattered stone, the moon was born. This giant impact hypothesis is the leading explanation for the moon's origin. It explains why the moon's composition is similar to Earth's mantle, why it lacks a large iron core, and why it orbits in the same plane as Earth's equator. The moon is not just a neighbor. It is a piece of Earth, torn away and reformed, a sibling born from violence and fire. There is water ice on the moon. For centuries, the moon was thought to be completely dry, a barren desert of rock and dust. But in recent years, we've discovered something surprising. There is water on the moon, not flowing rivers or lakes, but ice, hidden in the deep shadows of polar craters where sunlight never reaches. In these permanently shadowed regions, temperatures can drop to some of the coldest in the solar system, cold enough to trap water molecules for billions of years. Some of this ice may have come from comets or asteroids that crashed into the surface long ago. Some may have been delivered by the solar wind. This frozen water could one day support future astronauts, providing drinking water, oxygen, and even rocket fuel. In the darkest corners of the moon, life's most essential ingredient waits, patient and still. The moon's surface is covered in fine dust. Walk on the moon, and your boots sink into something strange. Not sand, not soil, but regolith, a fine, powdery dust made from billions of years of meteorite impacts. Each strike shatters rock into smaller and smaller pieces, grinding the surface into a layer of dust that can be several meters deep. This dust is sharp, abrasive, and clingy. It sticks to everything: boots, gloves, spacesuits, and equipment. Astronauts described it as smelling faintly like gunpowder, though no one knows exactly why. Without wind or water to smooth it, each grain remains jagged and rough. The dust gets everywhere, coating visors, clogging mechanisms, and drifting softly in the low gravity. It is the moon's skin, ancient and untouched, a blanket of shattered stone that has lain undisturbed for eons. The moon has extreme temperature swings. On the moon, there is no atmosphere to trap heat or shield the surface from the sun's rays. This means temperatures vary wildly between day and night. During the lunar day, which lasts about 2 weeks, surface temperatures can soar to 127 degrees Celsius, hot enough to boil water. But when night falls and the sun disappears, temperatures plummet to minus 173 degrees Celsius, colder than anywhere on Earth. These swings happen slowly, over the course of weeks, as the moon rotates in its leisurely orbit. Standing on the moon, you would feel the sun's heat with brutal intensity. And then, as darkness fell, the cold would creep in like a slow, relentless tide. The moon does not know moderation. It lives in extremes, bright and scorching, or dark and frozen. The moon is about 1/4 the size of Earth. Compared to other moons in the solar system, Earth's moon is unusually large. Most planets have tiny moons, captured asteroids, or distant chunks of ice. But our moon is about 1/4 the diameter of Earth, making it one of the largest moons relative to its planet. This size has profound effects. It stabilizes Earth's axial tilt, which keeps our seasons regular and our climate relatively stable over long periods. Without the moon, Earth might wobble chaotically, making life much harder to sustain. The moon's size also creates the spectacular solar eclipses we experience, a cosmic coincidence where the moon appears almost exactly the same size as the sun in our sky. Large, loyal, and essential, the moon is not just a companion. It is a partner in Earth's story. A day on the moon lasts about 29 Earth days. Time moves differently on the moon. One full day from sunrise to sunrise takes about 29.5 Earth days. That means 2 weeks of continuous sunlight followed by 2 weeks of unbroken night. There's no dawn that lasts an hour, no gentle twilight. The sun rises slowly over the horizon and climbs across the black sky for days, casting long, sharp shadows. Then it sets, and darkness falls for another fortnight. This slow rotation is the result of tidal locking with Earth. The moon turns just once for every orbit it completes, keeping the same face toward us and stretching its days into long, patient cycles. On the moon, time is not measured in hours, but in weeks. A rhythm as ancient as the orbit itself. The moon has mountains taller than any on Earth. The moon may be smaller than Earth, but it has towering peaks that rival our highest summits. The Montes Apenninus, a mountain range along the edge of the Mare Imbrium, includes peaks that rise over 5,000 meters above the surrounding plains. Some individual mountains reach heights comparable to Mont Blanc, or even parts of the Himalayas. These peaks were formed not by tectonic activity, but by the violent impacts that shaped the moon's surface billions of years ago. Massive asteroids and comets struck with such force that they threw up rings of mountains around the impact sites. Today, these silent giants stand frozen in place, bathed in sunlight or cast in shadow, their slopes untouched by wind, their summits never climbed. The moon's mountains are monuments to ancient violence, still standing after billions of years. You would weigh much less on the moon. If you could step onto the surface of the moon, you'd feel lighter, much lighter. The moon's gravity is only about 1/6 that of Earth's. If you weigh 60 kilograms on Earth, you'd weigh just 10 kilograms on the moon. This low gravity changes everything. You could jump higher, throw farther, and lift objects with ease. Astronauts bounced across the surface in slow, graceful arcs, moving in ways impossible on Earth. But this lightness comes with a cost. Without strong gravity to hold it down, the moon cannot retain an atmosphere. Gases drift away into space, and without air, there is no protection from radiation, no cushion against meteorites. The moon's gentle pull is both a gift and a limitation. A world where movement is effortless, but survival is hard. The moon glows because of the sun. The moon does not produce its own light. It has no fire, no heat, no luminous core. What we see when we look up at night is reflected sunlight, borrowed and gentle. The sun's rays strike the moon's dusty surface and bounce back toward Earth, painting the night in silver and gray. Depending on the angle, we see different amounts of the illuminated side, creating the phases we know so well: crescent, quarter, gibbous, full. The moon is a mirror, silent and still, catching the sun's brilliance and sending it softly earthward. When the moon is full, it reflects only about 12% of the sunlight that hits it. The rest is absorbed by the dark, rough surface. But even that small fraction is enough to light our nights and stir our wonder. There are dark plains on the moon called seas. When you look at the full moon, you can see darker patches scattered across its surface. Early astronomers thought these were bodies of water and named them Maria, the Latin word for seas. Mare tranquillitatis, Mare serenitatis, Mare imbrium, but there is no water there. These dark regions are vast plains of solidified lava, formed billions of years ago when the moon was still geologically active. Massive impacts cracked the crust, and molten rock welled up from below, flooding the low-lying basins. Over time, the lava cooled and hardened into smooth, dark rock. These ancient lava flows give the moon its familiar face, the patterns we see and recognize, the shapes that inspired myths and stories across every culture. The seas of the moon are dry, silent, and frozen in time. The moon has thousands of craters. The moon's surface is scarred with craters, some tiny, some vast. They range from small pits just a few meters across to enormous basins hundreds of kilometers wide. Each one tells the story of an impact, a collision with an asteroid, comet, or meteorite that struck the surface with tremendous force. Without an atmosphere to burn up incoming objects, the moon has been bombarded for billions of years. On Earth, erosion, weather, and tectonic activity erase most craters over time. But on the moon, they remain. Some are billions of years old, preserved exactly as they were the moment they formed. The largest, the South Polacan Basin, is over 2,500 kilometers across and may be one of the oldest impact structures in the solar system. Every crater is a clock marking time in stone and silence. Moonquakes occur deep beneath the surface. The moon may seem dead and still, but deep within, it trembles. Moonquakes, the lunar equivalent of earthquakes, shake the interior of the moon in subtle, rhythmic pulses. Some are caused by the gravitational pull of Earth, as tidal forces flex and stress the moon's interior. Others are triggered by the cooling and contraction of the moon's crust, which causes it to crack and settle. Still others, known as deep moonquakes, occur hundreds of kilometers below the surface and can last for hours. Unlike Earth's quakes, which fade quickly, moonquakes ring like a bell, vibrations echoing through solid rock with little dampening. Seismometers left behind by Apollo astronauts recorded these tremors for years. The moon, though cold and quiet, is not entirely at rest. It still shifts, still settles, still hums with ancient energy. The moon has no magnetic field today. Earth is wrapped in a protective magnetic field that shields us from harmful solar radiation. But the moon has no such shield. Billions of years ago, it may have had a magnetic field generated by a molten core, much like Earth's. But as the moon cooled and its interior solidified, that field faded and eventually disappeared. Today, the moon is magnetically quiet. Some rocks brought back by astronauts show traces of ancient magnetism, frozen into the minerals when the field still existed. These remnants are clues to the moon's early history, hints of a time when it was hotter, more active, and perhaps more Earth-like. Now, without a magnetic field, the solar wind strikes the surface directly, slowly wearing away atoms and shaping the thin, invisible exosphere that clings to the moon like a whisper. A solar eclipse happens when the moon blocks the sun, One of the most breathtaking sights in nature occurs when the moon passes directly between the Earth and the sun. For a few precious minutes, day turns to night. The temperature drops. Stars appear. The sun's outer atmosphere, the corona, blazes in a halo of silver light. This is a total solar eclipse, and it only happens because of a cosmic coincidence. The moon is about 400 times smaller than the sun, but it is also about 400 times closer to Earth. This makes them appear nearly the same size in our sky. As the moon drifts farther away over the eons, this perfect alignment will eventually end. One day, there will be no more total eclipses. But for now, we are living in a rare window of time when the moon and sun align just so, creating one of the universe's most beautiful accidents. A lunar eclipse happens when Earth blocks the sun. When the Earth passes between the sun and the moon enters our planet's shadow. But it doesn't disappear. Instead, it glows a deep, coppery red. This happens because Earth's atmosphere bends and filters sunlight, scattering blue light and allowing red wavelengths to pass through. That red light falls softly on the moon, painting it in shades of rust and amber. A lunar eclipse can be seen from anywhere on Earth's night side, and it can last for hours. Unlike a solar eclipse, it's safe to watch with the naked eye. There's something haunting and beautiful about seeing the moon dim and redden, a reminder that even our closest companion moves through shadows, touched by Earth's presence in ways both subtle and profound. The moon's far side looks very different. For most of human history, we only knew one side of the moon. The far side remained a mystery until 1959, when a Soviet spacecraft finally photographed it. What it revealed was startling. The far side is much more heavily cratered than the near side, with far fewer of the dark lava plains we call Maria. Scientists believe this difference may be due to the moon's slightly lopsided internal structure. The crust on the far side is thicker, making it harder for ancient lava to break through and flood the surface. The far side also lacks the familiar patterns we see from Earth. It looks alien, ancient, and untouched. It's a reminder that even something as familiar as the moon holds secrets. Half of it remains hidden, a landscape we will never see from home, waiting quietly in the dark. Humans have only visited the moon 6 times. Between 1969 and 1972, 12 humans walked on the surface of the moon during 6 Apollo missions. They planted flags, collected rocks, set up experiments, and took photographs that changed how we see ourselves. But since 1972, no one has returned. The moon has been silent, undisturbed except by robotic landers and rovers. Those 12 astronauts remain the only people to have ever stood on another world. Their footprints are still there. Their equipment still rests where they left it. The flags, now likely bleached white by decades of unfiltered sunlight, still mark the spots where humanity reached beyond Earth. It has been over 50 years, and the moon waits. Patient, timeless, and perhaps wondering when we will come back. The moon stabilizes Earth's tilt. Earth's axis is tilted at about 23.5 degrees, and that tilt gives us our seasons: spring, summer, autumn, winter. But without the moon, that tilt would not be stable. Over thousands or millions of years, it could wobble wildly, causing extreme and chaotic climate shifts. The moon's gravitational influence acts like a stabilizer, keeping Earth's tilt steady and predictable. This stability has been crucial for the development of life. It allows for regular seasonal cycles, predictable climates, and environments where life can adapt and thrive over long timescales. Mars, which has no large moon, wobbles significantly, and its climate has changed dramatically over its history. The moon, silent and steady, holds Earth in balance, a guardian not just of the tides, but of the very seasons that shape life itself. Moonlight is much dimmer than sunlight. When the full moon rises and bathes the world in silver, it feels bright. But in reality, moonlight is incredibly dim. The moon reflects only about 12% of the sunlight that strikes it, and even a full moon is about 400,000 times dimmer than the sun. That soft glow we see at night is just a faint echo of daylight, scattered and diffused. Our eyes are remarkable, though. In low light, our pupils dilate and our rod cells, sensitive to brightness rather than color, take over. This allows us to see by moonlight, though in shades of gray rather than vivid color. For most of human history, the moon was our only source of natural light after sunset. It guided travelers, inspired poets, and marked the passage of time. Dim, yes, but enough to see by, enough to dream by. The moon moves in an elliptical orbit. The moon does not circle the Earth in a perfect circle. Its orbit is slightly elliptical, meaning that sometimes it is closer to us and sometimes farther away. At its closest point, called perigee, the moon is about 363,000 kilometers from Earth. At its farthest, apogee, it is about 405,000 kilometers away. This difference may not seem like much, but it's noticeable. When the moon is near perigee and also full, we get what's often called a supermoon. It appears slightly larger and brighter in the sky. When it's near apogee, it looks smaller. The moon's path through space is not rigid or fixed. It shifts, flexes, and wobbles in subtle ways, influenced by the sun's gravity, the shape of Earth, and its own momentum. Even in orbit, the moon dances. A blue moon is not actually blue. The phrase "once in a blue moon" refers to something rare, and in astronomical terms, a blue moon is simply the second full moon in a single calendar month. It has nothing to do with color. Most months have one full moon, but because the lunar cycle is about 29.5 days, and most months are 30 or 31 days, occasionally two full moons squeeze into the same month. When that happens, the second is called a blue moon. Very rarely, atmospheric conditions, such as particles from volcanic eruptions or forest fires, can scatter light in such a way that the moon actually appears blue or green. But this is extremely uncommon. Most blue moons look just like any other full moon, silver, soft, and glowing. The name is poetic, not literal. a reminder that language and sky often meet in metaphor. The moon has been a calendar for millennia. Long before clocks or written calendars, people looked to the moon to mark time. Its phases are regular, predictable, and visible to everyone. A full cycle from new moon to new moon takes about 29.5 days, close enough to a month that many cultures base their calendars on it. The word month itself comes from moon. Ancient civilizations used lunar calendars to track seasons, plan harvests, and schedule rituals. Some cultures still do. The Islamic calendar, for example, is purely lunar. Even today, holidays like Easter and Passover are timed according to the moon's phases. The moon has been humanity's clock, hanging in the sky for thousands of years, patient and unchanging. A timekeeper written in light and shadow. The moon appears larger near the horizon. Have you ever noticed that the moon looks huge when it's rising or setting, but smaller when it's high in the sky? This is not an optical illusion caused by atmosphere or distance. It's a trick of the mind called the moon illusion. When the moon is near the horizon, your brain compares it to trees, buildings, and mountains, making it seem enormous. When it's overhead, there's nothing to compare it to, so it looks smaller. In reality, the moon's size in the sky doesn't change. You can test this by holding up a coin at arm's length. The moon will cover the same amount of space, whether it's rising or at its peak. It's a beautiful reminder that perception is not always reality. Our minds shape what we see, even when we're looking at something as constant as the moon. The moon has no sound. If you could stand on the moon and clap your hands, you would hear nothing, not even the impact of your palms. Sound needs a medium to travel through: air, water, or solid material. On the moon, there is no air. Vibrations from your clap would travel through your spacesuit and your body, but they wouldn't reach your ears from the outside. The silence is total and absolute. Astronauts communicated through radios because sound waves cannot cross the vacuum. Explosions would be silent. Footsteps would make no noise. Even a meteorite strike, which would send dust and debris flying, would happen in perfect quiet. The moon is a world of silence, where only light moves freely, and stillness is the only sound. Astronauts left items on the moon. When the Apollo astronauts departed the moon, they didn't take everything with them. Weight was precious, and every kilogram mattered for the return journey. So they left behind tools, backpacks, cameras, and even the lower stages of their lunar modules. Flags were planted at each landing site, though they have likely been bleached white by solar radiation. More poignantly, they left memorial plaques, a small sculpture called Fallen Astronaut, honoring those who died in the pursuit of space exploration, and family photos. These objects remain exactly where they were placed, untouched by wind or rain. The moon has become a museum of human ambition, a gallery of artifacts frozen in time, waiting in stillness for the day we return. The moon's gravity creates tidal locking. The same gravitational force that gives us tides has also locked the moon's rotation. Over billions of years, Earth's gravity pulled on the moon unevenly, creating a tidal bulge. This bulge acted like a brake, gradually slowing the moon's spin until its rotation matched its orbit. Now, the moon rotates exactly once for every trip it makes around Earth, keeping the same face toward us at all times. This phenomenon, called tidal locking, is common in the solar system. Many moons orbit their planets in the same way. It's a quiet example of gravity's patience, shaping motion over eons, smoothing out the chaos, and settling into rhythm. The moon and Earth move together now, locked in a dance as old as their existence. The moon has inspired myths across every culture. For as long as humans have looked up, the moon has sparked stories. In Greek mythology, it was Selene, a goddess driving a chariot across the night. In Chinese folklore, it houses Chang, a woman who drank an elixir of immortality and floated to the lunar surface. Some indigenous cultures saw the moon as a protector, others as a trickster. The Inuit believed it was a brother to the sun. The Maori saw it as a guardian of the night. The moon has been a rabbit, a man, a mirror, a boat. Its face has been read like a map of meaning, its phases interpreted as omens or blessings. No matter the culture, no matter the continent, the moon has always been more than rock. It has been story, symbol, and guide. Moonlight can cast shadows. On a clear night when the moon is full, you can see your shadow on the ground. It's faint, softer than a shadow cast by the sun, but it's there. Moonlight is bright enough to illuminate landscapes, cast silhouettes, and even allow you to read, though with difficulty. Before electric lights, people relied on the full moon to travel at night, to work, or to celebrate. Moonlit nights were safer, brighter, and more active. Even today, animals adjust their behavior according to the moon's phase. Predators hunt more successfully. Prey stay hidden. The world shifts in subtle ways under the moon's glow. It is light enough to see by, soft enough to dream by. A presence that shapes the night in quiet, silver ways. The moon's orbit is slowly changing. The moon's path around Earth is not fixed. It shifts and wobbles in subtle, complex ways. The plane of its orbit tilts slightly. Its distance varies. Even the speed at which it moves changes from month to month. These variations are caused by the gravitational pull of the sun, the shape of Earth, and the moon's own momentum. Over centuries, these small changes add up. Ancient eclipse records show that the moon's position has shifted slightly compared to where it was thousands of years ago. Astronomers use these records to refine their understanding of orbital mechanics. The moon is not static. It moves, shifts, and evolves, slowly tracing a path through space that will never repeat exactly. Even in orbit, there is change. The moon has been studied by dozens of missions. Since the dawn of the space age, more than 100 missions have been sent to the moon. Some have orbited, others have landed. A few have returned samples. The Soviet Union's Lunar program, NASA's Apollo missions, China's Chang landers, India's Chandrayaan orbiters, all have contributed pieces to our understanding. Each mission revealed something new. Maps of the surface, measurements of gravity, evidence of ice, seismic data, chemical compositions. Together, they paint a portrait of a world that is far more complex than it first appears. The moon is not a simple, dead rock. It is layered, dynamic, and full of mysteries we are only beginning to unravel. And each mission brings us closer to understanding not just the moon, but the history of the entire Earth-Moon system. The moon has almost no erosion. On Earth, wind and water constantly reshape the land. Mountains wear down. Rivers carve valleys. Coastlines shift. But on the moon, there is no wind, no rain, no flowing water. The surface changes only through impacts and the slow gardening effect of micrometeorites. A footprint made today could last 1,000,000 years. A crater formed 1 billion years ago looks almost the same as it did the day it formed. The moon is a frozen archive, a landscape that preserves its history in stone and dust. Every scar, every mark, every crack is still visible. The moon does not forget. It holds onto everything, patient and still, a surface unblemished by time's usual tools. The moon has been to Earth and back, in a way. Some of the rocks on Earth are pieces of the moon. Over billions of years, meteorite impacts on the lunar surface have blasted fragments into space. A few of these fragments, carried by chance and gravity, eventually fell to Earth as meteorites. Scientists have identified these lunar meteorites by comparing their composition to samples brought back by Apollo astronauts. They are rare, precious, and tell a story of violence and travel. A piece of stone, blasted from the moon by an impact, drifting through space for thousands or even millions of years, and finally landing here, on the world it once orbited. In this way, the moon and Earth exchange pieces of themselves, a slow conversation written in stone. The moon affects animal behavior. For centuries, people have believed that the full moon influences behavior. And while many myths are exaggerated, there is real science behind some effects. Sea turtles time their nesting to the lunar cycle. Certain fish spawn according to the moon's phases. Corals release eggs and sperm in synchrony with the full or new moon. Nocturnal animals adjust their activity based on how much light is available. Predators hunt more when the moon is bright. Prey hide more cautiously. Even some plants open or close their flowers in response to moonlight. The moon's light and gravitational pull create rhythms in nature, subtle but real. The natural world listens to the moon, moves with it, and follows its ancient, predictable cycles. The moon has rays extending from some craters. Look closely at images of the moon, and you'll notice bright streaks radiating outward from some craters. These are called rays, and they are made of material ejected during the impact that formed the crater. When a meteorite strikes the moon, it doesn't just create a hole. It throws debris in all directions, scattering bright, pulverized rock across the surface. Over time, these rays slowly darken as they are exposed to the solar wind and micrometeorite impacts. Fresh craters have bright, prominent rays. Older craters have faded or invisible ones. The rays are like timestamps, marking the age of impacts and showing how the surface evolves. They spread across the moon like frozen fireworks, evidence of ancient violence still glowing softly in the sun's light. You can see the moon during the day. The moon is not just a creature of the night. On many days, you can see it hanging in the daytime sky, pale and ghostly against the blue. This happens because the moon orbits Earth independently of the sun's position. Depending on its phase, it may rise before sunset or remain visible after sunrise. A waxing crescent might appear in the afternoon. A waning gibbous might linger into the morning. The moon is always there, circling, reflecting, shining. We just don't always notice it when the sun outshines everything else. But if you look carefully, especially in the early morning or late afternoon, you'll find it. A quiet reminder that day and night, sun and moon, share the same sky. The moon has been mapped in incredible detail. Thanks to decades of observation and spacecraft missions, we now have maps of the moon that are more detailed than maps of some parts of Earth. Every crater, every mountain range, every boulder larger than a meter has been cataloged. High-resolution images show the surface in stunning clarity. We know the elevation of peaks, the depth of valleys, and the composition of rocks in specific regions. Some areas have been mapped so precisely that future landers can target spots just a few meters wide. The far side, once completely unknown, is now as familiar to scientists as the near side. The moon, once mysterious and unreachable, has been measured, charted, and understood in ways our ancestors could never have imagined. The moon has no global magnetic field, but local patches exist. While the moon lacks a planet-wide magnetic field today, some regions of the surface have localized magnetic anomalies. These are small patches where ancient magnetism is frozen into the rocks, remnants of a time when the moon may have had a dynamo-generated field. Scientists believe these magnetic regions formed billions of years ago, perhaps from large impacts that generated brief, intense magnetic fields, or from the slow cooling of iron-rich lava. Today, these patches can deflect the solar wind slightly, creating tiny protective bubbles. They are fossils of the moon's magnetic past, clues written into stone, reminders that the moon was once more active, more dynamic, and perhaps more alive than it is now. The moon has helped us understand Earth's history. By studying the moon, we learn about Earth. The moon's surface is ancient, preserving a record of impacts that occurred billions of years ago. Earth, with its active geology, has erased most of that history. But the moon remembers. By dating lunar rocks, scientists have pieced together the timeline of the early solar system. They've learned about the late heavy bombardment, a period about 4 billion years ago when the inner planets were pummeled by asteroids and comets. This event may have shaped the conditions for life on Earth. The moon is a witness, a silent record keeper that holds memories Earth has long forgotten. In studying the moon, we read our own origin story, written in craters and stone. The moon has no rivers, but it has rills. Though the moon has no flowing water, it does have features that look like rivers. These are called rills, long, winding channels that snake across the surface. Some are collapsed lava tubes, tunnels where molten rock once flowed beneath a hardened crust. Others may have formed from flowing lava that carved channels into the surface. One of the most famous, Hadley Rill, was visited by Apollo 15 astronauts. It stretches for over 100 kilometers and reaches depths of 400 meters. These ancient riverbeds of stone are evidence of a time when the moon was geologically active, when lava flowed and the surface shifted. Now they lie empty, silent, and dry. Ghosts of rivers that never held water, carved instead by fire. The moon keeps one face toward Earth because of gravity. Long ago, the moon rotated faster. It showed us all of its sides as it spun, but Earth's gravity pulled unevenly on the moon, creating a bulge. Over millions of years, this gravitational tug acted like a brake, slowing the moon's rotation. Eventually, the moon's spin synchronized perfectly with its orbit, locking one hemisphere toward Earth. This process, called tidal locking, is irreversible under current conditions. The moon is now gravitationally locked, and it will remain that way unless something catastrophic happens. It's a slow, patient process, the kind that only works over deep time. And the result is the familiar face we see every night, unchanging, constant, always watching. The moon has helped with navigation for centuries. Before GPS, before compasses were widespread, sailors used the moon to navigate. Its position in the sky, combined with the stars, helped determine latitude and time. The moon's predictable phases and movements made it a reliable guide. Lunar eclipses were used to calculate longitude. Tides, governed by the moon, told sailors when it was safe to enter or leave harbors. Even today, some navigators use celestial techniques as backup. The moon is more than a light in the sky. It has been a tool, a map, and a companion for travelers across oceans and deserts. Silent, steady, and always visible, it has guided countless journeys home. Lunar soil could be used to build structures. One day, when humans return to the moon to stay, they may use lunar soil to build their homes. The regolith that covers the surface can be melted and formed into bricks, or sintered with focused sunlight or microwaves. This material is called lunar concrete, and it could be used to construct habitats, landing pads, and radiation shields. Using local materials would save the enormous cost of transporting building supplies from Earth. Some experiments have already tested this concept, and the results are promising. The moon's dust, so troublesome for equipment and spacesuits, could become the foundation for future settlements. What was once barren and hostile could, with human ingenuity, become the bedrock of a new home. The moon's gravity affects Earth's rotation, just as the moon pulls on Earth's oceans, creating tides. It also pulls on the planet itself. This creates a tidal bulge not just in water, but in Earth's solid crust. Over time, this tidal friction acts as a brake, very gradually slowing Earth's rotation. Billions of years ago, a day on Earth was much shorter, perhaps only 10 or 12 hours. As the moon pulls and Earth slows, the length of a day increases by about 1.7 milliseconds per century. It's almost imperceptible on human timescales, but over deep time, it adds up. The moon, in its quiet orbit, is slowly lengthening our days, stretching time itself. One day, far in the future, a day on Earth may last 50 hours, and the moon will hang even farther away, dim and distant. Some craters are named after scientists and explorers. The moon is a map of human achievement. Many of its craters are named after scientists, astronomers, philosophers, and explorers who advanced our understanding of the cosmos. Copernicus, Tycho, Kepler, Galileo. Their names are written on the surface in stone. Other features honor poets, engineers, and dreamers. Some are recent, named after astronauts or mission contributors. Naming craters is more than tradition. It's a way of saying thank you. The moon becomes a monument, not just to geology, but to human curiosity. And every name is a reminder that the moon is not just a place. It is also a destination, reached through thought, courage, and wonder. The moon smells like gunpowder, according to astronauts. This is one of the strangest discoveries from the Apollo missions. When astronauts returned to their lunar module after walking on the surface, they brought moon dust inside with them. And many of them reported the same odd smell, gunpowder or spent fireworks. The scent faded quickly as the dust was exposed to moisture and oxygen inside the cabin. No one is entirely sure why it smells that way. It may be due to chemical reactions triggered by exposure to the harsh lunar environment, or the breakdown of minerals in the fine dust. The moon, it turns out, has a scent. Faint, strange, and wholly unexpected. A reminder that even in science, there are mysteries that surprise the senses. The moon has seas with poetic names. The dark patches on the moon are called Maria, the Latin word for seas, though they hold no water. Early astronomers gave them beautiful, evocative names. The Sea of Tranquility, the Sea of Serenity, the Ocean of Storms, the Sea of Clouds, the Sea of Rains. These names carry a quiet poetry, a longing for connection between earth and sky. Though we now know these regions are plains of ancient lava, the names remain. They remind us that science and art are not opposites. They are partners. When we name the unknown, we make it part of our story. And the moon, dry and airless, becomes an ocean of meaning. The moon has been a source of inspiration for art and music. From Beethoven's Moonlight Sonata to Debussy's Clair de Lune, the moon has inspired some of humanity's most beautiful music. Painters have captured its glow on water, its reflection in windows, its rise over mountains. Poets have written of its light, its phases, its mystery. The moon appears in love songs and lullabies, in haikus and epics. It represents longing, change, madness, and peace. It is both distant and intimate, untouchable yet deeply familiar. Across time and culture, the moon has stirred something in the human heart. It asks us to look up, to wonder, to feel small and infinite at once. And in that inspiration, the moon becomes more than geology. It becomes meaning. The moon moves about 3.8 centimeters farther from Earth each year. This slow drift is caused by tidal interactions between the Earth and moon. As the moon raises tides on Earth, friction slows Earth's rotation and transfers energy to the moon, pushing it into a slightly higher orbit. The process is incredibly gradual, but over millions of years, it adds up. In the distant future, the moon will be too far away to cause total solar eclipses. It will appear smaller in the sky, less dramatic, less immediate. But that future is still unimaginably far off. For now, the moon drifts outward at the pace of a fingernail's growth. Slow, patient, and unstoppable. A reminder that even the most constant things are moving, changing, evolving over time. The moon has no twilight. On Earth, when the sun sets, we experience twilight, a gradual dimming as sunlight scatters through the atmosphere. But on the moon, there is no atmosphere to scatter light. When the sun dips below the horizon, darkness falls instantly. There is no soft transition, no golden hour, no lingering glow. One moment, the surface is bathed in harsh sunlight. The next, it is plunged into deep shadow. Stars appear immediately. The contrast is stark, absolute. This sudden shift makes the moon a place of extremes, where light and dark do not blend, but clash. It's beautiful in its sharpness, in its refusal to compromise. The moon does not soften its transitions. It simply is. The moon has helped us learn about impacts across the solar system because the moon preserves its craters so well. It serves as a natural laboratory for studying impacts. By analyzing the size, depth, and distribution of craters, scientists can estimate the history of bombardment in the inner solar system. This information helps us understand how often Earth has been hit in the past and how often it might be hit in the future. The moon, unchanging and scarred, is a witness to billions of years of cosmic violence. And in studying its surface, we learn not just about the moon, but about the dangers and rhythms of the solar system itself. The moon protects us by recording what we cannot see, a silent guardian keeping track of the stones that fall from the sky. The moon has been depicted in every form of media, from ancient cave paintings to modern cinema. The moon appears everywhere. It has been a setting for science fiction, a symbol in fantasy, a backdrop in romance. Films like A Trip to the Moon and 2001, A Space Odyssey made it a character. Video games let us walk on it. Documentaries explore its mysteries. Children's books turn it into a friend. The moon is endlessly adaptable, endlessly meaningful. It represents exploration, isolation, wonder, and home. In every story, the moon is there, shining quietly in the background or standing boldly at the center. It is humanity's most universal icon, a shared image that crosses every border and language. The moon will one day stop drifting away. Though the moon is currently moving farther from Earth, this will not continue forever. Eventually, Earth's rotation will slow enough that a day will equal a lunar month, about 47 current days. At that point, the Earth and moon will be tidally locked to each other. The moon will hover over one spot on Earth, and from that location, it will never rise or set. It will simply hang in the sky, unmoving. The rest of Earth will never see it at all. This distant future is billions of years away, and long before it arrives, the sun will have changed in ways that make such predictions uncertain. But for now, it's a thought. One day, the moon will stop running, and the Earth will turn its face toward it forever. The moon is a time capsule. Everything that has ever touched the moon is still there. Meteorites, lava flows, human footprints, spacecraft, flags. The surface preserves it all. In this way, the moon is a museum of its own history and of ours. Future explorers may one day visit the Apollo landing sites, not to disturb them, but to honor them. To see the same footprints, the same tools, the same experiments left behind decades ago. The moon remembers. It holds onto every mark, every moment, every arrival. And in its stillness, it offers us a mirror. A place where time slows, where history does not fade, where the past is not lost. The moon is memory made stone. And now, as the final fact settles like dust on ancient stone, let the stillness of the moon become your own. We have drifted together through craters and shadows, light and silence. We have touched the surface of a world that has no wind, no sound, no breath, only patience. The moon does not hurry. It does not forget. It simply is. For billions of years, it has circled our world, pulling the tides, lighting the dark, steadying the earth beneath our feet. It has been a clock, a guide, a companion, and a mystery. It has watched empires rise and fall. It has seen the first life crawl from the sea and the first human look up and wonder. And tonight, it is still there, hanging quietly above, glowing softly in the dark. You are part of this story too, not separate from the moon, but connected to it. The same forces that shaped its craters shaped the earth beneath you. The same sunlight that illuminates its surface warms your skin. You are made of stardust and time, just like the moon. And when you look up, you are looking at something that has always been there. Something that will always be there. A constant in a changing world. So let your breathing slow. Let your thoughts drift like dust across a silent plain. Let the moon's stillness become your own. Wherever you are, whatever weighs on your mind, know this. The moon is still turning. The tides are still rising. And the light, soft and silver, is still falling gently through the night. Sleep well, and thank you for journeying with us beneath the quiet glow of the moon.